So good morning to all of you. So I hope my voice is clear to all of you. So good morning to all of you. Okay, fine. I hope my voice. So we already have discussed about the hydration process in cement. When we are adding some amount of the water into the cement, then cement compound will react with the water and it will generate some amount of the compounds, complex compound. That process, when the cement is react with water and it will liberate some amount of heat, that process is generally is called as heat of hydration. That process is called as heat of hydration. And during heat of hydration, there is lots of amount of heat will be evolved. Why the heat is liberating? In order to gaining the strength. In order to gain the strength, the cement, the heat is liberating. So during its reaction, so some amount complex compound will be formed. So you just remember one thing, more is the fineness in the cement, more will be the heat of hydration. If the cement will be more fine in nature, then there will be more heat of hydration will be liberated. So what are the complex compound? That is box compound are I already told you. That is first one is called tricalcium aluminate. That is represented by C3A. Second one is called tetracalcium aluminoferrite, C4AF. Then third one is called dicalcium silicate, that is C2S. Then last one is called tricalcium silicate. This C3 and C2S, this C3 and C2S called are generally responsible to provide the strength to the cement. C3S and C2S generally responsible to provide strength to the cement. And C3S, C4F are generally responsible for the heat of hydration. These C3 and C4 are responsible for amount of the heat liberated. C2 and C3 are responsible for the providing the strength to the cement. So today we are going to discuss about the this is type of the cement. So type of the cement we are going to discuss today. So these are the types of the cement. Okay. So type of the cement, generally we can classify the type of the cement. So type of the cement generally, the, it is the property of the cement during the hydration vary according to the chemical composition, varying according to the chemical composition and the degree of the fineness. Okay, the degree of the fineness. So what are the property? The property of the cement we can vary by proportioning by changing the proportion of the C3S, C2S, C4AF, C3A. So we can vary the proportion of the box compound. So we can generate the different type of the cement. Also we can change the chemical composition. We can change the lime. We can change the silica amount. Okay. So by changing this, also we can generate the type of the cement, and also we can generate some different type of the cement by changing the degree of the fineness. If more is the fineness, then more is the heat liberated. Okay, less is the fineness, less is the heat will be liberated. So more is the less is the heat, low heat cement. More is the heat, the gain of strength will be more. That is rapid hardening cement. So based upon the chemical composition and degree of fineness, we can have some different type of the cement. Okay. So next point you read, it is I written. So it is possible to manufacture different type of the cement by changing the percentage of the raw material. By changing the percentage of the raw material. So I told you the most commonly used cement in construction, that is called OPC, ordinary Portland cement. Most commonly used cement in construction. If you are using any cement for constructing the building, roads, any highway, that cement you will see that is called OPC. Different grade are there, 33, 43, 53. General three grade are available in a market. Okay, 33, 43, 53 are representing what? That is called compressive strength of the cement at 28 days. Okay, so type of the cement, first I told you this is ordinary Portland cement. Ordinary Portland cement, that is coming under the type 1 category. They have categorized this type of the cement. Second one is called modified cement, that is coming under the type 2. Okay, that is called type 2 cement. Third one is called rapid hardening Portland cement. Rapid hardening Portland cement, that is coming under type 3. Then that is called low heat Portland cement, that is coming under the type 4. Then sulfate resisting Portland cement, that is coming out under the type 5. So if you add some additive, if you add some like some other additive, some ingredient, if you add additive to some ingredient, if you add to the Portland cement, then you can also generate different type of the Portland. Additive means what? We can add some blast furnace slag, we can add some amount of the pozzolanic compound, so we can generate some different types of the Portland cement. So there also we can Portland blast furnace cement, that is coming at type IS. Okay, Portland, that is blast furnace cement. Then that is called pozzolanic cement. Pozzolanic cement, if you add some pozzolana, okay, fly ash. Generally we are using fly ash as pozzolana. So if you use the fly ash alone, it has not cementing property. But if you use the fly ash along with the cement, then the fly ash has the cementing property. So it is coming under the type IP. Then air entrant cement, air entrant, that is generally used in US, United States, air entrant cement, that is IA. Then white Portland cement and color Portland cement. So these are the different type of the cement which are going to see in our next subsequent lecture. Okay. So next, this is ordinary Portland cement. So this is first we are going to see the ordinary Portland cement. So ordinary Portland cement, I told you this is the ordinary, this is the type of cement which generally used in our construction. So this cement generally used in our construction, and when there is no exposed to sulfates or soil or sulfate in the soil, or there is groundwater. Okay, so when there is the we are designing any building or any structure, when the structure is not exposed to any sulfate attack, the soil is not having any sulfate, or the groundwater table is not very high, then we can go for the ordinary Portland cement. So the chemical composition required, the chemical composition I already told you. So first we have to find out the lime saturation factor. Okay, in ordinary Portland cement, we have to find out the lime saturation factor. This is the formula by which you can calculate. So lime saturation factor generally for ordinary Portland cement, it is limited in between the 0.66 to 1.02. That is limited in between 0.66 to 1.02. So this factor limited. Why? Because if the lime amount will be more in ordinary Portland cement, that will be deposited as called as free lime. That will be deposited as it is called as free lime. That is called free lime, and the lime will generally make the cement to be unsound. Okay, the free lime make the cement to be unsound nature. Means there will be more volumetric expansion and shrinkage. Okay, so crack will be formed. If the lime will be very less, if you are providing very less lime in the ordinary Portland cement, then what will the problem? The problem is that it will be make the difficult. It would make difficult during the burning in the kiln. During the burning in the kiln, so all the ingredient I will not burn and will not have a proper clinker will not get. Okay, so if the lime saturation factor will be very less or very low, then all the ingredient which we are burning inside the kiln, that will not burn into definite proportion. Okay, so will not get the definite proper cement. The strength of the cement will not be adequate. So the lime saturation factor should always be not too less, not too high. So generally it must be present within this range, that is called 0.66 to 1.02. This PDF I will share with you. Then the insoluble residue that should not be more than 1.5%. And the percentage of SO3 that is limited by 2.5% when the tricalcium aluminate is less than 5%, and it should not be more than 2.8% when the tricalcium aluminate is more than 5%. And loss of ignition of the heat, that is maximum 4% should be there. If more will be heat will be liberated, then more crack will be generated and more atmospheric moisture will be penetrated into the structure. So as a consequence, the durability of the structure will decreases, and that will be ultimately the structure will collapse. And last one is called percentage of magnesium oxide, that is also limited to the 5%. Okay, so magnesium also equal more, that is also make the cement to be unsound. Okay, so that is the thing. Next type of cement, that is called modified cement. This is called modified cement. This is called modified cement. Let me clear this one. So modified cement, this is coming on the type 2 category. This is called modified cement. This is coming out under the type 2 category. So the modified cement, that is, it is a combination. It's combined low heat of hydration. So the modified cement has low heat of hydration as compared to the ordinary Portland cement, and a higher rate of heat of hydration, than compared to the low heat cement. So the heat of hydration should be always in between the ordinary Portland cement and low heat cement. Okay, it combines a lower heat of hydration, then ordinary Portland cement must have the lower heat of hydration and the higher heat of hydration than low heat cement, with rate of gain of strength similar to the ordinary Portland cement. So modified cement, its heat of hydration, it is less than ordinary Portland cement. Ordinary Portland cement, how much heat will be liberated? The modified cement must be liberated less heat as compared to ordinary Portland cement. But the amount of heat will be liberated in modified cement. It must be greater than the low heat cement. What is low heat cement? I will tell you next slides. But the rate of gaining of this strength of the cement, that is similar to the ordinary Portland cement. Okay. So where you will recommend this modified cement type 2 type category? The modified cement is generally recommended for use in structure where this moderately low heat of generation is desirable. Okay, or where the moderate sulfate attack may occur. Okay, so this cement is extensively used in United States. Okay, so generally when you are designing any massive structure, mass construction like dams, barrages, so retaining wall, so there we are considering this type of cement, because the heat of hydration will not be very more, so there will not be very the cracks will not be formed, very fine cracks will not be formed, and the rate of gain of strength will be very gradual, so we can get the strength gradually, not we are not getting the strength very rapidly. So we can use this modified cement in that. Mostly it is used in United States. Then third type of the cement, that is called rapid hardening cement. This is called rapid hardening Portland cement type 3. So rapid hardening, from name itself, we can understand this. The gain of strength of this cement is very rapid, very quick. We want the strength to be gained very quickly as compared to the ordinary Portland cement. So that's first point it is written. This type of cement develops strength more rapidly as compared to the ordinary Portland cement, as compared to the OPC, ordinary Portland cement. I mean, here in rapid hardening Portland cement, the rate of gaining of the strength is higher as compared to the OPC. OPC you can understand, ordinary Portland cement. The initial strength is higher. Okay. Okay, here in a rapid hardening Portland cement, the initial rate of gain of strength is very high, but final strength will be same. Final strength it will be same, but initially it will gain the strength very quickly, very rapidly, but it will same after 2 to 3 months. After 2 to 3 months, what is the strength gained by OPC? The same strength will be gained by the RSC. RSC means rapid hardening cement. Okay. And setting time for this type is similar to the Portland cement. What of the setting time? Means initial setting time, that is 30 minutes. Generally, we are considering the 30 minutes for ordinary Portland cement and 10 hours for the final setting time for the ordinary Portland cement. So setting time is similar as that of OPC, ordinary Portland cement. Okay. The rate of gain of strength occur due to what? I told you C3S and C2S are responsible for strength. C3A and C4A are responsible for heat of hydration. Okay. So C3, if you increase the amount of the C3S in the cement, the strength rate of gain of initial strength will be very high. C2S is responsible for later strength. If you want to strength to be more at later stage and after some period of time, then you want to increase the C2S. But if you increase the amount of C3S in the cement, initial strength will be very high. Initial rate of gain of strength will be very high. Okay. So the rate of strength gain occur due to increase of C3S, due to C3S. Okay, C3S what? Tricalcium silicate. And we also in the rapid hardening cement we also get this we are also getting this strength by finer grind of the cement. If more is the finer is the cement, or more is the finer particle of the cement, that will be more exposed to the water. If you add some amount of water into the cement, all the cement particle will be react with the water, and the rate of gain of strength will be very high. Okay, so that is one thing. You can increase the C3S compound, and also due to the finer grind of the cement clinker. Okay, so what is the minimum value of fineness that is required? That is 320 meter square by kg. 320 meter square by kg. So here rate of heat of evolution of higher than ordinary Portland. If you are gaining the strength is very rapidly, so the heat evolution will also be more, because heat of hydration is the only reason for the gaining of the strength of the cement. Okay, so rate of heat of evolution is higher as compared to the ordinary Portland cement. Due to what? Due to increase in C3S and C3 and higher fineness. So we are doing, we are increasing amount of the C3S and C3A, and also we are actually doing the fineness. We are actually doing the fine grinding of the clinker. So as a result, what is happening? The rate of heat of evolution is increasing. So as due to the rate of heat of evolution increasing, we are gaining this strength very rapidly, very quickly. Okay. And chemical composition and soundness, all the chemical composition and soundness requirement are similar to that of ordinary Portland cement. All the chemical composition, sound requirement, everything are similar to that of ordinary Portland cement. But here the rate of heat of evolution, that is higher than ordinary Portland cement, due to what? Due to increase of C3S and C3S, and due to higher fineness. That point you have to remember. That point you have to remember. So where you can use this rapid hardening cement? Where we can use this rapid hardening cement? So where you can use? So the use of this cement is indicated where rapid strength development is desired. So we want the strength to be gained very rapidly. Suppose we are designing any construction, and you cannot allow the construction to be happen very long period of time. So there you want to the structure to be gain the strength very quickly, and then we can use the structure for our serviceability requirement. So there we can use this rapid hardening cement, RSC, rapid hardening cement. So it's when this strength, early strength, that means 3 days strength is equal to 7 days strength of ordinary Portland cement. I mean how much the ordinary Portland cement, how much strength it will be gained at the age of 7 days. The same strength will be gained by rapid hardening cement at the age of 3 days. Okay, the 3 days strength will be equal to 7 days ordinary Portland cement. So where you can use, where the formwork we have to remove very quickly. Okay, because we have to use, we cannot we cannot delay the construction for long period of time, and we have to use the construction. Suppose you are designing any road, so traffic cannot stop for a long period of time. So you have to use the traffic very quickly. So you can use the rapid hardening cement in the case of road design. Okay, so that is one example. Rapid hardening cement you can use. So where the sufficient strength further construction wanted as quickly. So strength is to you want very quickly, so as quickly as possible. So there also you can use for this one. Okay, for construction at low temperature to prevent frost damage, capillary water, this type of cement does not use mass concrete. Mass concrete construction means suppose design of the dams, barrages, or any where any retaining wall. If you are designing any mass concrete structure, there we cannot use rapid hardening cement. Where? Why? Because the rate of heat of hydration will be very high. As the rate of heat of hydration will be very high, there will minor cracks will be formed. Okay, minor cracks will be formed, and because of the formation of the cracks, it may water will may seep into the structure, it may collapse the structure. Okay, so we want in mass construction we want the there is a gradual gaining of the strength. We not do not want the strength to be gained very quickly or very rapidly. That is the thing. So there is some special type of the rapid hardening Portland cement. So there is some special type. First one is called ultra high early strength cement. Ultra high early strength cement. Ultra high means, see, that rapid strength developed of this type cement is achieved by grinding the cement to very high fineness. Okay, to very high fineness. What is the fineness? 700 to 900 meters square per kg. Because of this, gypsum content has to be higher. Gypsum generally used as a retarder. Okay, in cement, gypsum we are using as a retarder means to delay the setting time. To delay the setting time. Sorry, to increase the setting time, or you can delay the setting time. Better you can say. So as the very we are actually grinding the cement to very high fineness. So the rate of heat of hydration will be very high. So the cement will gain the strength as quickly as possible. So in order to delay the setting time, we are adding some amount of the gypsum to the cement. Okay, so that is 4% generally we are taking. Okay, so why you are adding gypsum? I told you because of the high fineness. So, and high fineness, I told you, high fineness leads to the rapid hydration. Rapid hydration, therefore, high rate of heat of generation will be there as early ages, and a rapid strength will development will get. Means 7 days strength of rapid hardening Portland cement can be achieved at 24 hours. In 7 days, rapid hardening, how much rapid hardening cement strength will be there at the age of 7 days? We can get that amount of strength within 24 hours. You can imagine. Within 24 hours, we can get that strength. Okay. So at 28 days, at 28 the strength of gain, rate of strength of gain is not that much. There is a very little gain in strength at the age of 28 days. So generally it is used in the structure, okay, where early putting in service very important. Okay, we cannot delay the construction for very delay. We cannot delay the construction. We want to use that way or a construction very quickly. So there we can go for ultra high early strength kind of cement. And this type of cement contains no integral admixture. There is no admixture we are using in this type of cement. Okay. Last one is this is called extra rapid hardening Portland cement. That is called extra hardening Portland cement. Extra rapid hardening Portland cement. Extra rapid hardening Portland cement means here this type prepares by grinding calcium chloride with rapid hardening Portland cement. You have to remember this thing because you are engineer. You have to remember all this. So calcium chloride generally used as accelerator in this cement manufacturing. Gypsum generally used as a retarder, and calcium chloride generally it is used as accelerator. Means it will accelerate the setting. It will decrease the setting time. Okay, and that very quickly the cement will set. So extra rapid hardening cement we are actually preparing by grinding calcium chloride with rapid hardening cement. And what is the percentage of calcium chloride generally used? It should not be more than 2%. 2% by weight of the rapid hardening Portland cement. The percentage of calcium chloride it should not be more than 2% by weight of the rapid hardening Portland cement. So what is the use? Why we are adding calcium chloride into the rapid hardening cement? So what is the use of the calcium chloride? So by using calcium chloride, the rate of setting, I told you, the rate of setting and hardening increases. Rate of setting means what? It will, the setting time will decrease. The setting time will decrease and the rate of strength will increase very quickly. So the mixture is preferred to be casted within 20 minutes because you can see if you will delay the casting of the mixture, then it will set. Okay, so the setting time is very quick. So only we have limited the casting of this mixture to be 20 minutes, not more than that one. And the rate of heat evolution increases because here again we are grinding rapid hardening cement and also we are adding calcium chloride as a slate into the cement. So the rate of heat of evolution, the rate of heat of evolution increases as compared to the rapid hardening Portland cement. So, so it is more convenient to use at cold weather. Generally, when we are designing the structure where the weather is to be very cold, there we can use this extra rapid hardening Portland cement. The early strength is higher than rapid hardening Portland cement, but their strength is equal at 90 days. Early rate of gain of strength is very high as compared to rapid hardening Portland cement, but at the age of 90 days, the final strength will be remain same as compared to rapid hardening cement. Okay. So because of the calcium chloride, because of the calcium chloride, because of calcium chloride is a material that takes the moisture from the atmosphere, care should be taken to store the cement at dry place and for storage period not more than 1 month. This should not be deteriorating. Okay, because calcium chloride is generally it will extract the moisture from the atmosphere, and when you will extract the moisture from the atmosphere, the cement will react with the moisture and it will heat of hydration will produce, and the gain of strength will be there. So the cement quality will be deteriorate. If you use that type of cement during the construction, then that rate of gain of cement will not be adequate. That care to be taken. We should always put the cement in a dry place, or we should store in a dry state where it will not be contact with any atmosphere. Okay, and the storage period should not be more than 1 month. Within 1 month, we have to use this kind of cement. Okay, so this is the thing. And last today, next class we will talk about other types. So this is the last. This is called low heat Portland cement. So heat, I told you, strength is C3S, C2S. Heat is due to C3S, C4A. You remember this one. The strength in the cement that is due to the C3S and tricalcium silicate and dicalcium silicate, and the heat of hydration is due to heat. Heat thing is coming due to C3A, tricalcium aluminate, and tetracalcium aluminoferrite, C4A. Okay. So here low heat. Low heat means what? It contains less C3S and C3A percentage. Okay, and higher percentage of C2S. Higher percentage of C2S. So generally, low heat Portland cement C3S. If you increase the amount of C3S, the rate of gain of strength will be very high. So C3A will be very high because heat of hydration will be very high. So if you are decreasing C3S, you always remember the other C2S to be increased. Okay, the other C2S also to be increased. So low heat Portland cement, it contains less C3S because less heat of hydration will be there, and C3A, less, initial heat of hydration to be less. So it contains less C3S and C3A percentage, but here the C2S amount will be more. C2S amount will be more because C2S responsible for means the strength to be gained very later on. At later stage, we want the strength. We do not want the strength to be gained very rapidly or initial stage. We want the strength to be gained at later stage. So here in low heat Portland cement, higher percentage of C2S as compared to the ordinary Portland cement. So low heat cement, you remember, less C3S and C3A, higher C2S. Okay. What are the properties of the low heat Portland cement? The delay, the delay reduce the heat of hydration. Okay, so in low heat Portland cement, the heat of hydration to be reduced. The heat of hydration is to be reduced. Generally, in mass construction, we use this low heat Portland cement. Where? Because the gain we want to be happen gradually, and later stage we want the strength. So the heat of hydration is very less. The cracks will not be formed very quickly because if you design in a dam, there is rapid maintenance we cannot go for. The periodical, once we have to design the dam, it should go for 100 years, 200 years. Okay, the span of that one, lifespan. So in the case of mass construction, generally we prefer low heat Portland cement. Okay, so the limit of heat of hydration in the cement generally limited the heat to be 60 calorie per gram at 7 days and 70 calorie per gram at 28 days. So the heat of hydration is very less, and the gaining of the strength is very gradual. It should not gain the strength very quickly as compared to the ordinary Portland cement. Next, this one. So I told you it has a lower early strength. Early strength, it has very lower early strength, but as compared to the ordinary Portland cement, it has a very lower early strength. The strength to be gained very gradually. Final strength will be same as compared to the ordinary Portland cement, but early strength we do not want to be gained very quickly. So half of the strength we will get at the age of 7 days, and two-thirds of the strength we generally get at the age of 28 days. So you can imagine at 7 days what is the strength will be gained by ordinary Portland cement. We will get half of the strength at 7 days, and two-thirds of the strength of the ordinary Portland cement at 28 days. Okay, so the gaining of the strength is very gradual, not very quickly. So its fineness also very less. Fineness is also not less than 3,200 centimeters square per gram. Centimeter square per gram. Where we can use this low heat Portland cement? We can use this low heat Portland cement in mass concrete construction. You remember this one. We can use this one is mass concrete construction because it limits the rate of heat of evolution. It limits the rate of heat of evolution in the construction. As the heat of hydration, heat of evolution will be minimizes, then it will gain the strength very gradually, so the cracks will not be formed. If some cracks will be formed, then it will some moisture will enter into the crack. If the moisture will enter into the crack, then there will be durability of the structure will decreases. If the durability of the structure will decreases, then the structure lifespan will not be that much. Okay, so that is the in mass concrete structure, in the design of the dams, in the design of the weir, in the design of the retaining wall, in the design of the barrage. Generally, we are going for the low heat Portland cement. Okay, so what are the thing we have studied about? We have studied about the basic, the first cement that is called the normal cement, general cement, which were generally used in our normal construction purpose, that is called ordinary Portland cement, and we can different types of the ordinary Portland cement. That is, we have studied about the rapid hardening cement, low heat Portland cement, okay, extra rapid hardening Portland cement. So all the different type of the cement today we already talked about. So in next class, some special type of cement I discussed about, the sulfate resisting cement, white that is colored cement, or that is that is ordinary pozzolanic Portland cement that we are going to see in the next class. So different some other type of cement we will discuss in next class. So I hope you will enjoy this today class. So thank you. Have a good day. Thank you.